In this video, we will visualize the four fields of full forward aerofoil after calculation. Okay, in this video, we will visualize the velocity contour and the pressure contour, and we will visualize the streamline, and we put the streamline, and we will show the magnitudes of the velocity on the streamline. Okay, and this is other outlines. Okay, and from the previous video, after we calculation is finished. Okay, and this case we will get the final file of the calculation. In this is the cycle, the final cycle of the calculation. Uh, in this file is .fld file, and this file is will use in CFD Post to visualize four field. Okay, I will close the server. Okay, and this step, open the kicker and click on the post processor. Okay, and this case drag and drop the FLD file to the graphic window of SCT Post. Okay, this is your model, your geometry, and in this case, I will unshow the surface, and I will define the property of the plane, the plane 1. Go to the plane 1. The coordinates of the plane 1 perpendicular to the z direction at the middle, that is z is 0, is okay. And I will set up about the mesh, and I will set up, this is the boundary, right? This is the boundary, and I will set the boundary in using the white color by using the thickness is 200. Okay, and then I will unshow the supply external frame display location and middle clicks. Okay, and the first step we will we will plot the pressure contour in this plane. Go to the contour and click on display and select the variable, and I will show the contour of the velocity, the magnitudes of velocity. Okay, and right click. Okay, and then I will show the maximum value of the velocity. In this case is 4.5. Okay, in this case we can define the magnitudes of the color by go to this color bar and double click and define the maximum is 45500. Okay, and 4.5 minus 5, and we can set the this is, we can show the title is velocity, and we can set the display, and I will show the color of the letter change to the blue color and middle click. Okay, and style, I will show the style in the exponent form with the decimal of 2. Okay, the size of this one is set 1.2. Okay, and we can show the gradients display, and we can show, and these are the value we show in the min and the max value, and we will change to the manual with the interval of 5, right? Okay, we can show in this style 0 1.t x, and okay, and this is the title of this problem. We can show by go to this file, double click here, and then go to the title and change the click on the color and check to blue color, update by middle click. Okay, and this is okay. Listen to the color bar of the velocity. I will change the author, and I will change the title is velocity. The size is 1.2. Okay, and in this case we can move. Okay, this is the visualization of the control of velocity. Right, you can see the upper surface is higher velocity than the lower. Okay, and the next step we will show, in this case we will show the first we show the we show the control of velocity, and the next we will show the control of the pressure, right? Okay, in this case we can save the output status by click here to save current status, and I will check the select the directory of my folder of I forgot ex. No, in video clip. Ex. Okay. I will save. In this case, you can see this is your status output status file .sta. Okay, and the next step, I will unshow the color bar and double click on the plane, and we will change the variable from the magnitude of the velocity to the pressure, right? Before we will, okay, in this case, and then middle click on the graphic window. Okay, in this case you can see this is the distribution of the pressure contour, and I will set the magnitude of the pressure. In this case, the maximum value is 2.5 power e power 10. The minimum is minus 4 power 10. Okay, we can set up this property by click on the color bar and set the gradient, the maximum is the minimum is 2.5. Sorry, the maximum is 2.5. The maximum is -4. 2.5 minus 4. Okay, middle click on your mouse for update. Right now we can see the pressure distribution. Okay, and select the display, change the color of the letter to the blue color, and define the manual to find which two number of decimal is 2. The size is 2.2. Middle click, and you can see, and we will change the display. We will change to exponential form. Okay, and the next, change the author. The title is picture and size is 1.2. Okay, now we finish in the step of visualize for fields of the picture and velocity contour. This is the picture contour, right? Okay, if we want to see the velocity contour, we should to unshow the color bar of the picture and then go to click on the page and the contour, change the variable from the picture to magnitude of velocity and middle click for update, right? And then click the color bar of velocity. Yes, this is the visualization of the velocity. The upper is higher velocity than the lower surface. Okay, and as a result of this, you can see the distribution of the pressure when we change the pressure. Okay, the upper side is higher velocity due to the Bernoulli's principle, right? The high velocity is the low pressure side. Okay, this is the pressure side. This is the low pressure side. This is the higher pressure side. Okay, and as a result of this, the top is lower or the negative pressure. Sometimes in the top side is called the second side, and the bottom is called the pressure side. Okay, as a result of this, the magnitude of the lift force acts on the body is appear in the y direction. That is, lift is positive. Okay, in this case, is the visualization of the flow field over the airfoil of the pressure of the velocity and pressure control. And the next we will visualize the streamline. Okay, and we will show the velocity on the streamline. Okay, and in this case, I will click on display the contour and middle click to update. Okay, and the next step we will show the streamline. Click on the streamline. Okay, and set the property of the streamline 1. Okay, and I will create the starting point by using the line, create the line. And before that, I will change the display. Okay, the types of display from the tools, I will change to line and middle click for update. Okay, return to the starting point. And the setup of starting point, I will in this coordinate I will generate the point right in the first point and the second point right in x y z coordinate. Okay, and the x the you remember that our original point is about this location and this is the negative x, and I will define to the negative -1, the start x equal to -1, y is 0. For the bottom, top and the bottom, I will define for the bottom, I will define for y, the negative y is 0.25, and the positive is negative 0.25, and middle click for update, right? Now we can see the streamline. This we can define the starting point in this position, and we can add the number of your point 20, right? But in this case I will change to 10 point, and I will define the x the y condition is 0.1 and minus 0.1. Okay, this is your streamline. And in this case, we can go to the display, and we can show the number of calculation, right? You can increase the number of calculation. Now it's only for the T100, and I will define for 10,000 and double click, right? You can see this is the streamline. Right, this is the streamline from this is the streamline from the starting point to the outlet. Okay. Okay, I will change the color of the title. Double click here and change the color is from blue to white. Okay, and come back to the streamline. Setup of streamline, and I will show in the streamline we can show the plot. We can plot the contour on the streamline. Okay, we can plot the streamline, and we can show display of the magnitudes of velocity. Right, this is the magnitudes of velocity, and you can click on the show the color bar for velocity. Right, this is the color bar of the velocity. Okay, you can see this line in this position. This is the stagnation position, or the stagnation point of this flow, right? This is the streamline. Okay, this is the basics visualization of the flow field over the aerofoil. In this video, we visualize the picture contour, right? We visualize the and we visualize the first the contour, the picture contour, and we visualize the velocity contour. Okay, and we visualize the streamline. This is the streamline. Yes, this is the streamline. So the streamline is the contour of the velocity. Okay, and we can change the display, and the color of the letter is to white. Okay, this is the end video of this tutorial of the simulation of flow over the aerofoil. Okay, in this video we not only visualization but also we compare our numerical result with the literature, and we can see that our CFD result have a good agreement with the literature. Okay. Okay, and thank you very much for your attention on this tutorial of flow over an aerofoil, and this is the CFD simulation. Okay, for the next tutorial, we will investigate of flow over a buff body circular cylinder. Okay, and the behavior of this flow is unsteady, and we will simulate this problem by using the unsteady simulation, and we will visualize the Kama's vortex state behind the bulb's body. Okay, thank you very much for your attention in this video of visualization of flow over the aerofoil. Thank you very much, and see you to the next tutorial. Bye.